Okay, so last time we were talking about like solving trig, but this time we're actually going to talk about the inverse of trig, right? So we've talked in the past about like how reciprocals and inverses are not the same thing, right? We can see all of our reciprocals right here. We actually have different trig functions for our reciprocals, right? So when we're talking about, hey, the reciprocal of sine, that is cosecant, right? So when we, now we're going to go ahead and talk about inverses. And with inverses, we often use this little symbol here of like, it kind of looks like a little exponent to the -1. So that's our inverse symbol. We've seen that before with function notation. But when it comes to our trig functions, we actually use the term arc, right? So when I'm talking about the inverse of sine, I'm going to actually say arc sine, the inverse of cosine, arc cosine, inverse of tangent, arc cotangent, and so on, right? So as you can see over here in this little box with our Einstein here, was that right? Is that the arc notations are something only inverse trig functions get to use due to their relationship with the arc of the unit circle. All other functions must use the f of, right, that little -1 notation, but the arc is preferred with trig functions and easier to read anyways, right? Because that -1 fools us into thinking it's an exponent. Okay, so what does it mean when we're talking about our trig functions? And again, this was we did this with solving. We're just kind of thinking about this now in general, right? So our example here is arc sine of 1/2. So this is asking, right, what angle has the value of 1/2? If you kind of wanted to see that in terms of our solving, right, is that you might say something like sine of x equals 1/2, right? That's what it's asking there. And we have gone over this. We know that that could be pi over 6. It could be 5 pi over 6. It could be 13 pi over 6. It could be 17 pi over 6. Or we actually could put it in negative as well, right? -7 pi over 6, -11 pi over 6, etc., right? We actually wrote that in terms of an equation when we were solving. And it has all these different values in terms of solving for it. Okay, so let's think about this in terms of our graph. And that's going to kind of help us answer these in the general, because these are a lot of answers up here. We could keep going and keep going. All right, so if we look at our sine function, we know, right, from our sine function is that we're going to have one period here, and it's going to go ahead and repeat it. So an inverse simply just switches your x and y values, right? So when we're thinking about switching our x and y values here, our x values are now going to be -1 to 1, and our y values here are going to be some of the same notations that we have before. So we're going to have go up pi over 2 here. This is going to be pi, 3 pi over 2, and 2 pi, and then negative pi over 2, negative pi, -3 pi over 2, -2 pi. All right, so now looking at these, and again, we're kind of taking this graph where we're just switching our x and y values. So when we had a x value of pi over 2, 1, we're now going to have the value 1, pi over 2, 0, 0, negative pi over 2, pi, and it's going to kind of snake its way down here, and then I'm going to snake its way pi, 0, -1, 3 pi over 2, -1, 2 pi. So it kind of snakes its way through here. Oops, sorry, let me just kind of, my Apple Pencil is not, there we go. We'll start over again here. Just kind of snakes its way up and down that y-axis. All right, so like we said here, right, it says our arc sine should look like a grapevine winding its way up and down the y-axis. That it does, right? It's like winding up and down. And as you know, inverse graphs are a reflection of each other over the line y equals x. So we can see here over on the side that it has, if we actually put both of them together, yes, they are going to be that reflection over the line y equals x. So we can see here, of course, y equals cosine x and y equals arc cosine x are very similar. The graph of y equals to the sine graph, excuse me. But the graph of y equals arc tangent x is different. That's to be expected. So let's go ahead and see what we kind of get when we flip this guy here. So we're now going to scale our graph again. So I'm going to go pi over 2. Oops, let me switch that to black. So pi over 2, pi, 3 pi over 2, 2 pi, negative pi, oops, excuse me, negative pi over 2. Fit that. Negative pi, negative 3 pi over 2, negative 2 pi. So on these, it's kind of course, easy to start with some asymptotes here. Let's use our pink for our asymptotes. So we know that there's going to be asymptotes at pi over 2 and negative pi over 2. So there's now going to be asymptotes at pi over 2 on your x-axis and negative pi over 2. 3 pi over 2, sorry, negative 3 pi over 2 and 3 pi over 2. Those are where those asymptotes are going to happen. And then when we graph this, right, we have some at 0, 0. We kind of come up here through pi over 4 down here. And we, of course, get really close to these asymptotes, but don't actually go through them. Same thing here. And one more. So it looks a little bit different, kind of like a ladder or something that you're stepping up on those. So these are our graphs of our inverses, but as you can kind of see here, there's obviously a problem with it, and that's what we're going to get to here, which is that I even kind of preface it, right? But there is a huge problem with those inverse graphs. They are not functions. So algebraically, this plays out a problem where I say determine the arcsine of 1/2. How do you know which angle I'm talking about, right? Kind of scrolling back up here. Again, when I'm talking about these, how do you know which one to choose from? All right. So there are infinitely many possibilities. Therefore, we limit the range for inverse functions, which means that we limit the domain of the original function. So we're therefore, which means we limit the domain of the original. So this region is chosen based on the portion of the original function around the y-axis that would be the 1 to 1. So we're going to go ahead, we're going to highlight that portion of our graph. So when we're thinking of the graph of sine of x, let me pull, actually I'll pull from here. Let's pull blue here, right? We are going to go ahead, we're going to be talking about this portion right here. So when we think about graphing it, we are just going to, we're going to be graphing through this portion right here. And we're only going up to pi over 2, and we're going down to negative pi over 2. So what this means is that it has a domain, right, from negative 1 to 1, because that's our range of our original function. But now our range, because we're only working in this portion from negative pi over 2 to pi over 2, our range is going to be from negative pi over 2 to pi over 2. So when we're thinking about our sine functions, we're thinking about, hey, what quadrants are we working in? And for us, we're going to be working in quadrant 1 and quadrant 4. Really keep that in mind, right? So arcsine, when we're answering those, we're answering with quadrant 1 or 4. All right, let's now take a peek at cosine. For cosine, we're going to go ahead and we're going to graph from 0 to pi. So looking at our graph here, we're going to have pi over 2 and pi, and we're going to have, right, again, flipping your x and y values. It almost is easier to start with. We have 0, 1, So 1, 0, pi over 2, 0, negative 1 pi. So we're going to kind of come through here and flip down this way. And again, thinking about some domain. So our domain is going to be from negative 1 to 1. That's always going to be our domain because that's the range, of course, of your original function. But now our range is from 0 to pi. So thinking about in terms of cosine and arc cosine, we are in quadrant 1 and quadrant 2. Again, keep these in mind when you're answering them. All right, and for our tangent here. For our tangent, we're just going to be graphing one period in there, the one starting at 0, 0. So we're going to have negative pi over 2 and positive pi over 2. And when we graph this guy, let's probably also put some asymptotes in here, right? We go ahead and get really close to these asymptotes, but don't actually touch them. And again, let's talk about that domain. So that domain for this one is actually going to be negative infinity to infinity because it's the range of our original one. But now our range is going to be from negative pi over 2 to pi over 2. And again, thinking about our quadrants, so we're working in quadrant 1 and quadrant 4. All right, so those quadrants are going to come back in particular, all right? So from this point forward, your answer should only be in the range allowed for each trig function, okay? So take a peek there, think about your range for all of them, right? And also take a note that any Q or quadrant 4 angles should be written as negative quadrant 1 angles, okay? That's really key there. Always answer in radians and, of course, no calculator. So if we're now thinking about the arc sine of 3 pi over 2, you can, of course, right, we're thinking about sine, so if you want to think about, hey, what quadrant are we talking about? We're talking about quadrant 1 and 4. It's positive, so we're going to be in quadrant 1. And we're thinking about what angle gives us 3 pi over 2. That's going to be pi over 3. Arc cosine, so cosine, we are going to be in quadrants 1 and 2, negative 1. We're all the way over on that x-axis. That's going to be all the way over 4 pi. Arc tangent, we're thinking about quadrant 1, quadrant 4. It's going to be, arctangent is going to be 1, that's positive. That's going to be root 2 over 2, which is pi over 4. Arc cosine, and again, I'm just drawing our quadrants to remind us what we're dealing with. Okay, we're now going to be in quadrant 2 because it's a negative amount. Negative root 2 over 2 is going to be 3 pi over 4. Arc sine is going to be quadrant 1 and quadrant 4. It's negative. We're going to be in quadrant 4. Negative pi over 6. That's going to give that y value a negative 1/2. All right, arc cosine. We are in quadrant 1, quadrant 2, but this is, of course, out of that range, right? So 2 is out of the range of what we're talking about, so we're not going to be able to have anything there. So this is, it's out of the domain is what I should say of your arc. It's out of the range of your cosine, out of the domain of your arc cosine. So this is going to be undefined. All right, so just kind of think through in terms of what quadrant you're in and which one that you can answer for. All right, so here's some problems that if we kind of think through them, right, don't overthink them, but we might have to sketch out a few things. Of course, remember the ranges and no calculators. So we're taking the secant of arcsine of 4 over 5. So when we're thinking about this, right, it's the arcsine of 4 over 5, meaning that it's going to be an angle here that, oops, I guess I'd have to actually draw our triangle here, right? So it's going to be an angle here, and it's going to be sine, so it's going to be opposite over hypotenuse. All right, so we're now looking for the secant of that, so we're looking for hypotenuse over adjacent. We know that this side is going to be 3, so this is going to be 5 over 3. So you just got to kind of think through, hey, it's actually giving you some side angles here and what side angles they're going to be there. All right, so we have arctangent, so the secant of arctangent of -3 over 5. Oh, goodness. Okay, well, this is going to be our negative values. So we know in here, right, this is going to return quadrant 4. All right, but secant in quadrant 4 is positive. So just kind of heads up on that one before we get started. Let's think about our angles, or our triangle here. And we have theta. We're going to have 3 over 5 because it's our tangent. This means that this side is going to be, so 9, 25, root 34. So our answer for this one is square root 34 over 5. This one's pretty nice because right away I'm looking at, hey, this right here cannot happen, right? So 3 is not in the domain, meaning undefined. So just always look for those. It's kind of like when you have an absolute value that equals a negative, you can see it right away. Hey, it's going to be undefined. All right, we have an arc cosine of root 5 over 5, and we have, there we go, there's my triangle. We're taking the sine of that arc cosine. So I actually see this as something that is already, we know that this guy is going to be root 5, and this is going to be 1 if you think about it as 1 over root 5, and then it's rationalized, meaning our other side is going to be 2. So if we're thinking about the sine of this, it's going to be 2 over root 5, which is going to be 2 root 5 over 5. And you didn't have to do it that way. For instance, here, if we kind of clear our side lengths here, we could also say that this is 5, and this is square root of 5, and you can kind of figure it out from there on that one. I just like to see it as rationalized when possible, so I like to keep this as square root of 5, 1, and 2. All right, so thinking about this one, we have the sine of arc cosine of 3x. Well, let's start with, hey, this 3x. And we know that we can only, if we're thinking about our cosine, right, arc cosine here, our domain is going to be from -1 to 1. So when we have these, we know that this 3x, right, so -1, 3x, and 1. We know that it's going to be in between those. So if we go ahead and we divide by 3, we get -1/3 less than or equal to x less than or equal to 1/3. So if we're thinking about this in terms of interval notation, you might have been able to do that kind of in your head, right? Is that all these values in here have to be between -1/3 and 1/3 for you to take the sign of it. All right, so moral of the story here is, of course, you're going to use your arc instead of using that symbol, and then just kind of think through, of course, what quadrant you can be in for your functions. Arc sine is going to be from quadrant 1 and quadrant 4, same thing with arc tangent, and then of course arc cosine is that one that's a little bit different. You're now from quadrant 1 to